Welcome back to our calculus assignment. Today, myself, Nicholas, Jim, and Kit, we are going to teach about the equation of lines and planes. In today's topic, we're going to cover changing line equation from a vector to a scalar equation, and a scalar equation of a line to a vector equation, and also a vector equation of a plane to a scalar equation. First off, we're going to start off on how to change a scalar equation of a line to a vector equation. The vector equation of the line is given as 2x plus 3y negative 8 equals 0. The coefficient for x and y are the normal to the equation. Therefore, we use the dot product to find the direction vector of the line, which gives us 2x plus 3y equals 0. With the equation 2x plus 3y equals 0, we move 3y to the opposite side and it becomes 2x equals negative 3y. Let's make y equals 2, which eliminates the denominator to find the value of x. Therefore, x equals negative 3, which gives us the direction vector of negative 3, 2. In the first example, we will substitute the point 2, negative 2 into the equation. We would then get a value of negative 10, which means the point is not on the line. By substituting 7, negative 2 into the equation, we would then get 0, which means the point is on the line. We would then get a vector equation of point 7, negative 2 with direction vector s, negative 3, 2. And remember, for R3, there is no scalar equation of a line, therefore we can ignore it. But we can change the vector equation of R2 back to a scalar equation. In order to change the vector equation of R2 into a scalar equation, what we need to do is to find the normal and the constant of the line. So this is another example. Given 0.05 and direction vector 15 is the vector equation of a line. We then use dot product to find the normal. 15 dot product xy, we will be getting x plus 5y equals 0. Moving to the right side of the equation, we'd be getting 5y equals negative x. Let's make y equals 1 to eliminate the denominator, which makes negative x equals 5, which in turn makes x equal to negative 5. The normal would then be x equals negative 5 and y equals 1. The equation of the normal will be negative 5x plus y plus c equals 0, and we will have to sub in the point from the vector equation of the line into the scalar equation to find the constant, which makes c equal to negative 5. Negative 5x plus y negative 5 equals 0 is the scalar equation of the line. After this, we can learn how to change a vector equation of a plane to a scalar equation of the plane. Same thing, a vector equation has 3 axes, x, y, and z, and 2 direction vectors. And we need to find the normal and the constant for the scalar equation. This vector equation consists of 2 direction vectors. So we will have to cross product the direction vectors, because any vector that is perpendicular to the plane is perpendicular to the direction vectors. The value we found is 63, 2, negative 7. After that, let's use the normal and make it 63x plus 2y minus 7z plus d equals 0. To find the constant, substitute in the points given in the vector equation 63x plus 2y negative 7 plus d. And we will find the constant. The values we found for d are negative 240, and this is how it is written as 63x plus 2y negative 7z minus 240 is the full scalar equation of the plane. For an equation of the line, we would sometimes be asked on how to find the vector equation of a line. Given the first example, we will have to draw a diagram. As we observe the diagram, 1, 7 is a point on the line. The line is perpendicular to the x-axis. We will have to find a direction vector that is parallel to the line perpendicular to the x-axis. The direction vector we are going to use is direction vector S04. Vector equations in R3 cannot be found in R3 because the scalar equations do not exist in R3. Therefore, the examples given below is one of the ways to find a vector equation of a line in R3. In question D, for the next example, we are given direction vector 130 and a point 021. Therefore, it is written as xyz, point 021, and the direction vector S130. In question C, given the vector equation of a line parallel xyz equals 1, negative 73 with direction vector 472 and through the point 243. Therefore, the vector equation of the line will be point 243 with the same direction vector 47 and 2. Now, this is a summary of vector equations of a line in R2 and R3. That is all period 4. We hope you guys had a fun time with changing line equation from scalar to a vector equation and a vector to a scalar equation.